Alright, we are back using trigonometry again with our identities sheet. This video is all about making the algebra and trig connection. It's one of the most important things you can do to help yourself not make mistakes in trigonometry, is relate your trig work back to algebra. So, just to help you make that connection, some of you may be aware of the rainbow connection with Kermit the Frog. You know, you all laugh at Mr. Rump's jokes. You're going to just take mine for a minute. We are making connections today all between algebra and trigonometry. So to start, simplify the expression using your algebra skills. If I have w plus w, I have two w's. Using that same knowledge, I could say that I'm going to simplify cotangent plus cotangent to be 2 cotangent of x. Keep in mind that we are simplifying expressions. We are not solving equations, so there are no equal signs here. We're just drawing arrows to show how things simplify. Alright, Katie simplified the following expression and found an answer of x minus w. Do you agree or disagree, and why? Go ahead and pause your video. Decide whether or not you agree or disagree. Alright, I hope that you guys came up with the fact that you disagree. I'm going to say that the reason Katie simplified this, she just went like this and said, alright, well, x minus w. But the w is also being divided by the y. So if you want to split this up, you would have to write x minus y over y minus w over y. The y's will cancel in this first fraction. I don't know why this box is happening. But the y does not cancel in the second fraction. So this should be your simplified answer, not that one. Alright, so let's use it for a connection. This we just said you would want to split up into xy over y minus w over y. Y's will cancel. X minus w over y. So likewise, here's our rainbow connection. I'm going to take the sine of x times tangent of x over tangent of x. Split that up with the fraction 1 minus tangent of x. And now I'm going to simplify. So tangent and tangent are going to cancel. I'm left with the sine of x minus 1 over the tangent of x. But using our identity sheet, we know that that can simplify into the sine of x minus cotangent of x. So that's where the trigonometry is going to come in, that you can use your identities, but the algebra skills are exactly the same, making that connection. Continuing with our algebra, we know that x squared divided by x will simplify to just be x, because really this just means x times x all over x. Those will cancel. So here, x and x, these are going to cancel, and we'd be left with just y. So using that with our trig connection, cosine squared divided by just cosine, one of those is going to cancel, and we'll be left with just cosine of x. Here, secant cosine divided by secant, your secants will cancel, and you are left with just cosine. Well, I don't know why that jumped. We'll just take it. Take it for what it is. Cosine of w. Smartboard's having issues. Alright. Simplify x plus y, all divided by x. We want to break this up into two separate fractions, so we're not canceling anything too soon. Here, x and x are going to simplify to just be 1. Again, we're carrying these over, not with equal signs. And this will end up being y over x. So making that trig connection, we can break this up into sine of x over sine of x plus 1 over sine of x. These are going to simplify to 1, and we know that 1 over sine of x, that's going to be the same thing as cosecant of x. So again, it's the algebra that gets you there to simplify, and then make that trig connection and use your identities. Factoring, everybody's favorite. This right here, we're factoring. We're not setting it equal to 0, we're not solving for x, we're just factoring. This will factor into the difference of 2 squares. So 2 plus x and 2 minus x. Please notice 4 was in front, so the 2's are in front. X is in the back, so the x's are in the back. Making that trig connection, we're going to consider tangent squared to be our x squared. So this will become 2 minus tangent of x and 2 plus tangent of x. Again, the 4 was in the front, so 2 and 2. Tangent squared was in the back, so tangent and tangent. Okay, this time we're going to FOIL. So we've got 2 factors and we want to multiply them together. So remember, first, outside, inside, and last. So that can condense down. We'll get y squared plus y minus 6. Making our connection now, we're going to count the sine of y to be just like our y in the previous one. So we'll say first, outside, inside, and last. So minus 6. These ones are just signs. They don't have a square on them. So we can combine like terms just like we would in algebra. And you can see how these two things are very similar. Alright, expand the following. This is one of the most illegal math moves that students will make. I'm done, right? False. Don't do it. This square right here means you need to take whatever is in parentheses and multiply it by itself, which is going to require some FOILing. Your final result should be x squared plus 2xy plus y squared. So likewise, students have a tendency to say, great, this will just be sine squared plus cosine squared and I'm done. Don't do it. This square right here means you need to take sine of x plus cosine of x and multiply it by sine of x plus cosine of x. So we'll get our first outside inside. Ooh, that should not have a 2 on it. My apologies. I'm ahead of myself. Cosine of x, sine of x, and our last cosine squared. Alright, so sine squared plus cosine squared. And then I've got these two terms that are actually the same term. I've got a sine and a cosine. I've got a sine and a cosine. So I have 2 sine and cosine. So the last thing to think about our identity is sine squared plus cosine squared is equal to 1 we'll have our 2 cosine of x times sine of x. Now, you'll learn later that this condenses to something else, but for right now, don't worry about it. You could leave your answer just like this. Factor. We are looking for things that multiply to 1 and add to 2. So starting with x and x, I'm going to go plus 1, plus 1. Don't set it equal to 0. Don't solve for x. This is just simplifying expressions. So similarly, cosine squared of x looks a lot like that squared term. 2 cosine of x looks a lot like that linear term. And this 1 matches our constant term. So this will factor in this same way, except instead of just x, we're going to have a cosine of x. Rainbow connection made. Alright, Dave simplified the equation a squared plus b squared equals c squared to be a plus b equal to c. Is his answer reasonable or unreasonable, and why? I want you to pause, and I want you to see if you can come up with an example to justify why he's right or to justify why he is wrong. Did you take the time to pause your video? If you didn't, pause it now. Think about it. Alright, his answer is definitely unreasonable. I've provided 3 different examples where a squared plus b squared equals c squared, but a plus b does not equal c. A squared plus b squared equals c squared, but a plus b does not equal c, etc. Okay, and you can come up with many, many, many more examples to show that, Dave, I'm sorry, you are wrong. So here's our algebra trig connection with that. We have a very, very, very important identity that you will use and use often. That's sine squared plus cosine squared. So we have our sine squared plus cosine squared equals 1. That Pythagorean identity, which also led us to tangent squared plus 1 equals secant squared, and 1 plus cotangent squared equals cosecant squared. You may not make the assumption that you can just go like this and say that sine of theta plus cosine of theta is equal to 1. It's not going to happen, okay? There are a few instances where it does happen, and actually if anybody can come in and tell your teacher about the one instance or find a few instances where sine plus cosine does equal 1, great. But as a general rule, do not be taking these square roots. You're going to end up like Dave, and it's not going to be good. Alright? So, summary. Don't let algebra be the reason that you struggle in trig. As long as you are making what I call legal math moves. Alright, so things that are okay mathematically to divide out by, to multiply by, all of that, you'll be fine. Alright, you'll use your trig identities to substitute in, and it'll help simplify your answers even more than algebra will allow for. But as long as you're not making mistakes like this, alright, you'll be just fine. Make sure you make that connection.